Algebra 1, Section 9.4, multiplying special cases. Just going to run through a few examples here. You have y plus 11 squared in example 1a. You need to realize that means y plus 11 times itself. A common mistake is to think that you just square the y and square the 11. If you're thinking that, you are misapplying a rule that is true for products that is not true for sums. What we need to do is take y plus 11 and multiply it by y plus 11. Sometimes textbooks will use the word expand. Expand does not just mean rewrite it the way I've written it there. Expand actually means do the multiplication, do the simplification, and write it in standard form. So y squared would be the f in FOIL, plus 11y would be the O, plus 11y would be the I, and 11 times 11 is 121. Again, you want to simplify the middle two terms. This is going to be y squared plus 22y plus 121. And right there, if you look at the correct answer, is proof that you don't just square the y and square the 11. There's a middle term. There's a linear term there. And y squared plus 22y plus 121 would be the correct answer. Similar to a problem where it's a difference instead of a sum, we're going to multiply 3w minus 6 times itself. Don't try to take a shortcut and think that you can just come up with the answer based on the problem. Rewrite it like that. That takes 5 seconds to rewrite it, and then apply FOIL. This would be 9w squared minus 18w, another negative 18w, and then plus 36, and then again simplify the middle terms. 9w squared minus 36w plus 36 is the correct answer. So if we were in class right now, we would do this little bit of a activity, a little bit of an exercise in mental math. I'm just going to show you what they would have you to do. But the question is using mental math, meaning don't use a calculator, don't figure anything out on paper. Just try to do it in your head. If you want to pause the video right now and try to do these two problems in your head, go ahead. Okay, but what they want you to do is see this as 81 times 81 being 80 plus 1 times 80 plus 1. They'd like you to see this as a distributive property problem. And if you were able to do 81 squared in your head, 81 times 81 in your head, you likely did some sort of mental activity in which you did this. And 80 squared, 80 times 80, of course, is 6,400. 80 times 1, and then 1 times 80, and then 1 times 1. That would be 6,561 when you add all those up. 6561. Now someone might ask, how are you going to assess us on that? Even if you were here and you were taking tests, how are you going to assess us on that? I'm not going to assess you on something like that, but it's a really good mental exercise to be able to do something like that in your head. It shows that your mental math abilities are where they need to be. Try something similar to 81 squared with 59 squared. Again, if you want to pause the video a sec, go ahead. And what they want you to see is 59 is 60 minus 1 times 60 minus 1. And 60 squared, or 60 times 60, that'd be 3,600, minus 60, minus 60. I'm just using FOIL like we learned in a previous lesson. Negative 1 times negative 1 would be positive 1. Okay? And again, if you multiplied this in your head, this is kind of the mental activity that you're doing. You did have to subtract those 60s and then add a 1 back in. Let's see, 3,600 minus 120 would be 3,480, plus 1 would be 3,481. And there was no need for a calculator there. Okay, now again, if you can't do that, it's not the end of the world, but this was the exercise. Before we do that problem there, let me just make up a problem. How about 3x plus 5 times 3x minus 5? And then we'll come and apply what we do here to this problem. 3x times 3x would be 9x squared. 3x times negative 5 would be negative 15x. 5 times 3x would be positive 15x. And 5 times negative 5 would be negative 25. So in a way, what I am doing is still the same as we've done in previous problems and in a previous section, which is I'm foiling. But notice that the middle two terms this time, these two add up to 0, okay? So 9x squared minus 25 would be our answer. This is known as a difference of squares. Your book would term this as a difference of squares. And a difference of squares, because 9x squared is a perfect square, meaning you can take the square root of it and get a convenient expression, which would be the 3x that we started with at the first position of both binomials. And you can take the square root of 25 as well. It's 5, and that's not a coincidence that these two numbers are 5. That's where the 25 came from. So it's a difference of squares because it's a difference, subtraction, of two perfect squares. And this is just the way these types of problems work out. And really, this is the thrust of this section, multiplying special cases to get you to see what's going on with these, the previous problem, and then also this one, which is known as a difference of squares. Now let's apply that same idea to this one up here. P to the fourth times P to the fourth. Again, this says its origins in chapter 8, which I know we skipped, but let me just remind you, as I did once before, that you add the exponents. P to the fourth times P to the fourth is P to the 4 plus 4, which is P to the 8th. And if you understand what happens in a difference of squares, meaning that the multiplication is the same binomial, but different by a middle sign. That's the only difference. You got P to the fourth minus 8, P to the fourth plus 8. In all of these cases, in the case of a multiplication like this, again, classified as difference of square, I know I keep using the term, the middle two terms are going to add up to 0. So you don't really need to take the time to write it, as I did write it down here in this problem. I mean, just think about what's going to happen here. This is going to be 8p to the fourth. This is going to be negative 8p to the fourth. Every time those are going to add up to 0 in this special case. So I'm going to leave it out. And negative 8 times positive 8 is negative 64. All right, and then one more example. And this is much like the mental math from before, having you multiply 43 times 37. I'm just going to roll to the answer here. They would have you multiplying 40 plus 3 by 40 minus 3. 40 plus 3 by 40 minus 3. Somewhat of the same mental activity there, except it's a difference of squares. And your final answer there would be 1591, 1,591. Thank you.